Shown here is just a subset of all the horizontal wells drilled in the Midland Basin in Texas. Managing these wells and attempting to understand their relationships to the encompassing stratigraphy is a daunting task. Now add in detailed stratigraphy, as shown here, and the task at hand quickly becomes overwhelming. Questions like what zone did a well land and toe in? Was the well toe up or toe down? How tortuous both aerially and stratigraphically was the well path? And did the well traverse stratigraphy or parallel it are now easily and quickly answered in Transform's new well targeting workflow. We zoom in on a base map to show that the wells in the Midland Basin are located in west central Texas. Here, we activate a Permian paleogeographic map around the Midland Basin and see that the depositional environment is primarily continental shelf to deep basin carbonates just east of a paleohighland known as the Central Basin Platform. We now activate a Permian facies map that shows the Midland Basin to be a complex mix of continental shelf sediments and continental clastics to the far west. To the right is the Permian stratigraphic type section for the Midland Basin, consisting mostly of complex carbonate sediments. This presentation will cover the complete section from the top of the Clear Fork Formation down to the base of the Strawn. We again illustrate the complexity of the horizontal wells targeting different stratigraphic intervals in the Midland Basin. The well targeting workflow will first be described and illustrated on 5 concocted wells that are highly exaggerated to quickly illustrate the workflow. Then we will show the workflow on all of the horizontal wells in the project. The well targeting workflow is launched from the Geology main menu pull-down. The workflow has a Setup Area tab and then 3 more tabs to QC and view the results. All that is needed in the workflow is a list of wells and a stack of stratigraphic horizons. There are some options to control where the horizontal well computations start by setting an azimuth parameter, and there is also an option to winnow down the wells that are only contained within the horizon extents. The horizons can easily be added by dragging and dropping a strat column into the workflow. A Select Horizons option also allows for the addition of any other horizons. When horizons are added to the workflow, their stratigraphic ordering is automatically determined. The computations are now computed for the 5 wells shown in the view. A set of wellbore intervals are computed to illustrate the intersections with the stratigraphic layers. The computations are precise and are geometrically computed exactly where the well paths cross the horizons. All of the information is now contained in all of these intervals. A quick run through the computer results is shown here. This will be covered in greater detail later. The Wellbore Results tab shows all of the computations of the wellbore and general relationships to the stratigraphy. Things like where the wellbore landed and towed stratigraphically, length of the horizontal segment, vertical and horizontal tortuosity, was the well toe up or toe down, and many other parameters are captured on this tab. The Zone Results tab displays all of the results as a function of reservoir zone. Here, things like percent in zone and footage in zone are displayed. The QC Wellbore Stratigraphy tab shows a more in-depth view of the results along a stratigraphic cross-section. Here, each well is displayed in detail in relation to the stratigraphy. The table on the left of the view allows for complex searching and sorting of the wells and their results. We will now compute the results for all of the horizontal wells in the field. Again, we select the well list, here, all of the horizontal wells, and then reapply the stratigraphic column to obtain all of the horizons. After the results are computed, it is easy to search and sort to QC and analyze the results. For example, an easy analysis to perform is to separate out those wellbores that are toe down from those that are toe up. The user simply sorts on the toe difference column and then finds all negative values that are toe down wells. These rows are selected and either a well list can be made or they can be immediately viewed in a 3D view. The same is done to find all of the toe-up wellbores. Another powerful analysis is to quickly make a well list or display in 3D those wellbores whose results have exceptionally high heel-to-toe TVD differences. This can be a quick way to potentially find problematic surveys or point out wellbores that went awry during a geosteering operation where dramatic corrections may have been attempted. Most horizontal wells are aerially drilled along a straight line in the heel-to-toe section. Certain drilling rules in Texas enforce this constraint. Wellbores that deviate from this rule are easily found in the well targeting workflow. The max aerial deviation column is sorted to find extreme values. This attribute finds the maximum deviations from a heel-to-toe straight line. These results are best QC'd by activating the base map, turning on the headphone guy, and then selecting the extreme values in the table. The base map will then zoom to these selected wellbores. Some of the most powerful analyses in the well targeting workflow are the easiest to do. For example, to find out which wellbores were optimally drilled in a target reservoir zone, the Results tab allows the user to select a desired reservoir zone, sort on which wellbores spent all or most of their entire length or percentage in that reservoir zone, and then QC these wellbores in a 3D scene by selecting the wellbores in the table and launching them in a new 3D view. The bounding horizons of this reservoir zone are added to the view to QC the optimal wells for this zone. Lastly, we show the Wellbore Stratigraphy tab where the details of the wellbores are analyzed in relation to the stratigraphy they pass through. For example, sorting on the heel zone column and then selecting wellbores that heeled into the lower Sprayberry allows for detailed analysis of the wellbores landing into the lower Sprayberry. Selecting the toe up column can allow the user to QC toe up and toe down wellbore geometries in relation to stratigraphy. Selecting the toe difference column and then sorting the column allows the user to quickly assess potentially bad survey data or geosteering problems. Activating the zone mode allows the user to place a series of distance markers that shows the exact reservoir zone thickness at the selected distance along the well path. Selecting the wellbore zone mode allows the user to place distance markers that show the true vertical depth between the wellbore and each stratigraphic boundary. Launching the camera icon at the top right of the workflow allows the user at any point to capture a detailed image of the workflow for export to a report or presentation. Finally, all of the wellbore and zone-based attributes can be written out as well attributes to Transform's database for further analysis in the MVStats workflow.